show that the functions b naught x, this is Fourier question, 1 to 3. And, yep, I've worked out 1 to 3, and I'm going to do those first of all. Okay, so show that the functions b naught x is 1 and b1x is root 3, 1 minus 2x are orthogonal with respect to the inner product. Fg is the integral from 0 to 1 of f of x times g of x dx. Okay, so what we need to do is, first of all, we have to do the inner product b naught of x with itself and check that it's equals, we have to check that each one is equals to 1 when it's inner product with itself. And then when we do them with each other, we've got to check that it's equals to 0. So this is going to be the integral from 0 to 1 f of x, well, it's b naught, which is 1 times 1 dx. So it's the integral from 0 to 1 dx. So that's x from 1 to 0, and then that's going to be 1. Because the integral of 1 with respect to x is x. Then we substitute in the 1 and substitute in the 0, and it comes up with 1. When we do the second one with itself, b1x with b1x. What we also say there is, because it's equals to 1, we say therefore normalised. So this next one, this is integral from 0 to 1. Let's put this down a line. It's too squashed otherwise. b1x with b1 of x. Integral 0 to 1. Now it's root 3, 1 minus 2x. And because it's with itself, it's actually that thing squared. Right, root 3 squared is 3. And then 1 minus 2x. So I'm using my margins. I picked this new type of notebook for this, so it's got nice margins. 1 minus 2x. So that's 1 minus 2x minus 2x. 4x squared. So this is 4x squared minus 4x plus 1 dx. So doing this with itself, so it's got to be equals to 1. Add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power, and that cancels. Then add 1 to the power, 1 and 0. 3 times. Now, when we put 1 in here, any power of 1 is always 1. So it's 1, 1, 1 there. So it just picks out the coefficients here. So it's 4/3 minus 2 plus 1. And when we put 0 in here, the value 0. Because it's 0 there, 0 there, and 0 there. 3 times 0. So 3 times 4/3 is 4. 3 times minus 2, minus 6. 3 times 1 is 3. Minus nothing, which is 1. So therefore, normalised. You can do some of these on your calculator as well. And then you've got to do it with itself. Doing with each other. b1x. So this is the integral from 0 to 1. 1 times root 3. That's 1 minus 2x dx. So this is root 3 times... so I've taken, that's 1 times root 3, I've taken that outside the bracket there, so I'm left with this to integrate. 1 integrates to x. 2x, add 1 to the power, divide by the new power. And the 2's cancel. So this is root 3, 1 minus 1, then minus root 3. And when we put 0, that's 0 as well. Put 1 in there, it's 1 and 1 there, 1 minus 1, and 0 there and there, that's a 0. So this is root 3 times 0, minus root 3 times 0, so that's all 0. So you can say therefore, orthogonal. Check my spelling there, yes, good. Okay, so that's question 1. Right, question 2. I've tried this once and this can get a bit fiddly, so I've got to be careful with this one. Right, let's get my notes. Here it is. Okay, right. number 2. Right, so let's talk about this one then. Show that Bnx is e to the j 2n pi x, where n is an integer, forms an orthonormal basis on the interval 0, 1 with respect to the inner product fg. So it's the integral from 0 to 1 of the first one as it is, and the second one is the conjugate. No, here it's the conjugate of the second one, and g is a complex conjugate. Okay, so what we need to do here, we've got fg. We need, it's going to be, what we need is the, let's look at the inner product of bm of x with bn of x. And then we can look at what happens when they're the same, which will, when they're the same, they've got to be equals to 1. Okay, so what we're actually hoping for, let's up here, the way that we're doing this in one step here, bmx, bn of x, it's got to be equals to, when they're the same, it's got to be equals to 1. It's like what we did in the previous one. When they're the same, here and here, they've got to be equals to 1. And when it's different, it's got to be equals to 0. 1 when m is equals to n. We need it to be equals to 0 when m is not equals to n. That's our aim that we need to show. Okay, so the way that the solution works for this one is we do we integrate and we put the m1 there, the n there, and the n there, and then we look at what happens in these two different cases. Okay, so this is, so it's the integral from 0 to 1, and that's from that there, 0 to 1, and it's e to the j 2 pi mx. This is for the m there, and it's there. It's got to be exactly as it is there. Now this one, you need the conjugate when it's, and we need the conjugate of this one here. So I'm just going to underline this here and look about the conjugate. If you remember e to the, oops, silly thing. It's a good thing. But e to the j theta is cos theta plus j sine theta. That was from the first year, first term complex numbers. Now, if you think, so this is now a complex number. This is real. Well, it was a complex number there, but this is real. This is imaginary. So the conjugate, so e to the j theta conjugate cos theta minus j sine theta. Now, if you think about an angle theta, and think about here, that should be a straight line, and it should be. Cos theta is adjacent to the angle, so that's along here, and then sine is opposite the angle, so that's this measure on this one here. So what we can have, that's minus theta. So cos of minus theta is actually the same as cos of theta because it's this distance here. So this is cos of minus theta. And then sine of minus theta is minus sine of theta because it's in the opposite direction. So this is going to be plus j sine of minus theta. Just going over my margin there. So it's cos of minus theta plus j sine of minus theta. Okay, because sine of, what's happened here, look, sine of minus theta is minus the sine of theta because it's in the opposite direction. So we can say, and if we write that back, e to the minus j theta. So basically the conjugate goes in there, which is what you would have hoped That's a little diagram to help you see that. So this is actually times e to the minus. Do I want a minus there? I don't want the minus to go in. I'll put the minus there. 2j pi, and it's n for this one, x dx. Okay, so where that's coming from, back to this. This second one here is here, and we need the conjugate. So we've got to put minus in. Could have said it in that short term there as well, but I didn't. Okay. Right, so let's simplify this a little bit. Integral, always handy to simplify things. E to the j, so now we've got pi mx, and then when we multiply these together, we add the powers, because it's got the same base e, so we add the powers, and that's a minus there. So we're going to go minus j 2 pi nx dx. So we're going to simplify now. Well, factorise these powers. There's a j 2 pi x in both of them, j 2 pi x, j 2 pi x, and it's m minus n dx. So I'll just rip this diagram out because I don't really need that now. Okay, and I need this bit of space. Right, so now we're going to look at our two cases. We've got the case where we need to think about what happens when m is n. And we need to make sure it's equals to 1. And then when m is not equals to n, and make sure that it's equals to 0. So let's do case 1. M equals n. Which is matching up here, look. Okay, if we let m equals n, then what we actually have is n minus n equals 0. So that bit there, m minus n, that's going to be 0. So this is actually going to be e to a big 0. So it's going to be integral from 0 to 1 of e to the 0, which is 1. Case 1. So we've got the integral from 0 to 1, e to the 0 dx. So it's integral from 0 to 1 of 1 dx, which is x, 1 to 0. X is 1 minus 0, which is 1, which is what we wanted. Okay. Then we need to do the next case, which is when m is not equals to 0, and show it's equals to 0, the answer. So case 2, m is not equals to n. I don't want it orange. It needs to be equals to 0. So if m is not equals to n, first of all, no, if m is not equals to n, then m minus n, now that is going to be equals to another integer. Okay, because m and n, look, I've underlined it up here, these are integers. Okay, and if you do one integer, take away another integer, you'll get a third integer. Okay, so we've got an integer. So up here, instead of writing m minus n now, I'm just going to put k, just to simplify things a little bit. So the integral, it becomes integral from 0 to 1, e to the j times 2 pi x times k dx. This is where I need to be careful. Let me write, oh God, I've got it written on this, I've already planned this out. So this is going to be equals to the integral from 0 to 1. Now if you remember here, what I've got here, look, e to the j theta, it's cos of theta, everything apart from the j in there, plus j sine theta, everything apart from the j in there. So this is going to be cos of 2k pi x plus j sine 2k pi x dx. Okay, so k is an integer. Right, if k is an integer, 2k is even. Okay, so, and then you've got 2k pi. Right, cos of multiples of 2k pi is 1. Sine of multiples of 2k pi is 0. And I'll do a little diagram to show this. Okay, because here, that's 1 pi, that's 2 pi. So multiples of 2, that's 4 pi, 6 pi. And along here, the cos axis, that's 1. But along there, the sine axis is at 0. Yeah, because the coordinates there are 1 across, 0 up. So the cos is 1. And the sine here is 0. Okay, so that has the effect of, that's equals to 0. The sine of 2k pi x is 0. So that simplifies things at that stage. So this is, so we want the integral now. Sine, the integral of cosine is sine 2k pi x. And when we integrate sine, we divide by the multiple of x. So the integral of cos is 2 pi x. The integral of cos is sine, and we divide by everything apart from the x. And the other one's naught, so it's going to be from 1 to naught. Okay, so this now, this is going to be sine of 2k pi times 1 divided by 2k pi, and the other one is going to be minus sine of 0 divided by 2k pi. Right, so here we've got sine of multiples, that's even, because 2k is even multiples of pi, and the sine, as we described over here, is 0. So that's 0, and the sine of 0 is 0, which equals 0. So, in summary, if m is equals to n, here, it's equals to 1. If m is not equals to n, it's equals to 0. And that's what we set out at the beginning, to be orthonormal. It's got to be equals to 1 if m is n, and 0 if m is not equals to n. And summarise nicely at the bottom. Therefore, so we can say, well, let's just summarise it a bit neater than that, as it's got in the solutions here. We can say bm x, bn of x is equals to 1 if m equals n, naught if m is not equals to n. So we can say, therefore, orthonormal. I'm pleased with myself to get to the end of that one, because I made a mistake the first time when I tried that one. Okay, there we are. The mistake I made is I went, not this one, this is correct, but the mistake I made was in here. I tried to integrate that, but if you let it be equals to 0 at that stage, it makes it a lot simpler. Okay, right, number 3. That one's done. Number 3, where's my little sheet, crib sheet for that one? Calculate the symmetric Fourier series for the periodic function ft is 0 for t between minus pi and 0, and 1 for t between 0 and pi, the period 2 pi. Calculate c0, the general term cn, and c1. Okay, so I'll start with cn here. is 1 over 2 pi, integral from 0 to pi. We don't need to worry about minus pi to 0 because it's just automatically equals to 0. So I'm going to start, just use that one there. And it's e to the minus j n t dt. Okay. Yes, I'm just checking I've got that right there. I think in the solutions they've started with C0, but I've started with Cn now, so that will do. Right, when you integrate this, so it's 1 over 2 pi, and if you remember, the integral of e to the kx dx is e to the kx divided by k plus c. Okay, so here, look, it's everything on there, everything apart from the x. So here, because it's t, it's everything apart from the t. So it's e to the minus j n t divided by minus j n. Okay, and this is the integral from 0 to pi. Okay, so we've got to substitute t is pi and t is 0, and do the pi answer, take away the 0 answer. So it's 1 over 2 pi, e to the minus j n pi divided by minus j n, then minus 1 over 2 pi e to the 0 over minus j n. Okay. Okay. Just trying to think of the best way to proceed here. If we've got, that's a little aside for up there. At this stage, the aside here, if you've got something divided by minus jn, as we've got here, you can multiply top and bottom by j, okay, and then the j squareds make minus 1. With that minus 1, that makes plus 1. So minus j squared is minus 1 times minus 1, which is 1. Okay, so you can replace this minus jn with a j on the top and an n on the bottom. Okay, so this means it's going to be, I'm going to take the j, so that and that can become j up there, that and that is a j up there. So it's j over 2 pi n and then it's e to the minus j n pi minus, and e to the 0 is 1. Where am I going with this one? That's right. Okay, so just to recap there, look, the minus j here can be, leave a j at the top. That's j over n, which is what I've got in there. That minus j there is j over in there, minus j there is j over in there. So the j comes out there with the n, and j with the n there. So that's now, it's a common factor for these two, and that's there. Okay, well, what exactly am I doing with this question? I got the answer. Let's just see. Calculate C0. So that's the general term n there. Underline. Right, so then we want C0. C0 is, if we go right back to the very beginning up here for this one, I'm not going to put a naught in there because we're dividing by 0 and that's really not allowed. So I'm going to go back to the beginning here. So it's 1 over 2 pi, integral from 0 to pi, e to the naught dt. So it's 1 over 2 pi integral naught to pi of 1 dt. 1 over 2 pi t pi naught. So it's 1 over 2 pi minus 0, and that is a half. So therefore C naught is 1/2. And just underline some of these answers and highlight them. So that's one of the answers that you need to give. There. There's another answer there. Okay. And the other one that you need is C1. Right, C1, I can use this answer here, the general one, with n is 1. N is 1 there, n is 1 there. I'm quite happy there to use that there. So C1 is j over 2 pi e to the minus j pi minus 1. Right, what you've got to remember here, so this is j over 2 pi, and then what we've got here, e to the j theta, it's what we had before, e to the j theta is cos theta plus j sine theta. So our theta in this particular case is minus pi, everything but the j. Okay, so it's cos of minus pi plus j sine of minus pi. Cos of minus pi is minus 1. I haven't quite finished, I shouldn't have done that. So that, sorry, what I did there, e to the j theta, or e to the minus pi j is here and here, and we've also got to put in that minus 1. Okay, so this is j over 2 pi, this is minus 1 on your calculator, this equals 0, minus another 1 at the end there. So this is minus 2 here, so that's going to cancel with that there, so that's going to be minus j pi. So C1 is minus j over pi. Check my answers. Yes, correct. Okay, so that finishes question 3.